Good morning, everyone. Welcome back. I'm Steve.
And I'm Scott.
And together we're Backyard Musings, Apple Valley, California.
And we are talking, we're going to give an update today, and we're going to talk about a new story, but science and technology is our deal.
What you're seeing on your screen right now is the Atlas interstellar comet, the one that we reported a couple days ago. This is a picture by Hubble of the comet. So we thought we'd just give that update. I thought it was very interesting. Leading into our next story. Let me advance the, I'll keep it up just for a little bit.
This is the one that's going to be passing between us and
Mars.
Yeah.
And then leaving the system.
Yeah. Right.
Some people, there's my Army buddies were texted an article about some astronomer or scientist thinks that it might be an alien ship in disguise.
Oh, Hailbot.
I'm thinking, that's
remember the Hailbot?
I saw it. I was standing in formation as a shaved tail second lieutenant, old dark 30, looking up and watching that thing. Like, wow.
Yeah, remember those people down in San Diego?
I did not contemplate suicide.
Yeah, that's just bizarre story. But anyway.
A cosmic jet aimed at Earth reveals how blazars, blazars, hurl particles to extreme energy, solving a long-standing mystery. Billions of light years from Earth, the blazar known as PKS 1424 plus 240, let's just call it PKS, has puzzled scientists for years. It was singled out by the IceCube Neutrino Observatory, not making that up, as the brightest blazar producing neutrinos, while also shining intensively in very high energy gamma rays detected by ground-based Cherenkov telescopes. Not making that up either. The mystery was that its radio jet seemed to drift unusually slowly, defying the assumption that only rapidly moving jets could drive such powerful emissions. You know you want to know more.
I could see a movie coming out of this, right? All these names.
The Eye of Sauron right there, man.
Yeah, okay. After 15 years of precise monitoring with a very long baseline array, VLBA.
The mother.
Yeah, I guess, astronomers have now created the most detailed image of this jet ever obtained. Quote, when we reconstructed the image, it looked absolutely stunning, says Yuri Kovalev, lead author of the study and principal investigator of the ERC-funded Muses project.
I like that, Muses, like backyard Muses.
Okay. Project at the Max Planck Institute for Radio Astronomy.
A lot of acronyms here.
Yeah, I'm not even going to go with that one. So, quote, we have never seen anything quite like it. A near perfect toroidal magnetic field with a jet pointing straight at us, unquote.
I wonder if that's an alien pointing it at us. Sauron's going to come and get us.
I don't know.
I wonder.
Their minds are going to wander on this one, I think.
I think so. Because the jet is directed almost exactly toward Earth, aliens, right? The light it produces is enormously amplified by relativistic effects. Quote, this alignment causes a boost in brightness by a factor of 30 or more, explains Jack Livingston, a co-author at MPIFR. At the same time, the jet appears to move slowly due to projection effects, a classic optical illusion.
So why do they do that? Why do they use some capital letters and then some lowercase letters?
Well, the I is in, maybe it means in or into. You know, so it's a little I.
F is a
like Mist of Pandaria. The M is capital, the O is little for of, and then Pandaria is capital, MOP.
Okay, I'm enlightened. This head-on geometry allowed scientists to peer directly into the heart of the blazar's jet, an extremely rare opportunity. Polarized radio signals helped the team map out the structure of the jet's magnetic field, revealing its likely helical or toroidal shape. This structure plays a key role in launching and collimating the plasma flow and may be essential for accelerating particles to extreme energies.
I wonder if it's like the start of a star. I don't know. I was probably prove my dumbness by saying that. All right, quote, solving this puzzle confirms that active galactic nuclei with supermassive black holes are not only powerful accelerators of electrons, but also of protons. The origin of the observed high-energy neutrinos, concludes Kovalev.
Discovery is a triumph for the Mojave program, a decades-long effort to monitor relativistic jets in active galaxies using the Very Long Baseline Array. What is a relativistic?
It's like theory of relativity, Einstein's, from a certain point of view, that this appears this way.
All right, enlighten
relative
again.
to where people are.
Scientists employ the technique of Very Long Baseline Interferometry, VLBI, all capital, which connects radio telescopes across the globe to form a virtual telescope the size of the Earth. Wow. This provides the highest resolution available in astronomy, allowing them to study the fine details of distant cosmic jets.
I think these people might have been Navy. Navy comes up with acronyms for everything in the Marine Corps. So that's what I think. Quote, when we started Mojave, the idea of one day directly connecting distant black hole jets to cosmic neutrinos felt like science fiction. Well, it feels like that right now. I feel that way.
It does.
Today, our observations are making it real, says Anton Zenzus. Not making that name up, Zensus, director of MPIFR and co-founder of the program.
I wonder if he beat Joe Smith out for that position. You think? Maybe just because of his name.
The name.
This result strengthens the link between relativistic jets, high-energy neutrinos, and the role of magnetic fields in shaping cosmic accelerators, making a milestone in multi-messenger astronomy.
That's a new one. Multi-messenger astronomy.
Lots of new today. Yeah.
Like stuff's being conveyed to you. Okay, so we got some background definitions and stuff for you here. A blazar is a type of active galactic nucleus powered by a supermassive black hole that launches a jet of plasma moving at nearly the speed of light. What makes a blazar special is its orientation. One of its jets is pointed within about 10 degrees of Earth. This alignment makes blazars appear bright across the electromagnetic spectrum and allows scientists to study extreme physical processes, including the acceleration of particles to energies far beyond those achieved in human-made accelerators.
The VLBA, Very Long Baseline Array, is an array of 10 antennas, or maybe it should be antennae.
Yeah, antennae. I think you're right on that one.
At locations across the continental United States and in Hawaii and St. Croix, which operates in the Very Long Baseline Interferometry. Ferrometry. VLBI mode. Spacings between the antennas vary up to approximately 10,000 kilometers, providing angular resolution on the sky as fine as 50 micro arcseconds.
Ooh.
Okay, whatever that is.
Sounds impressive.
It sounds small.
Mojave, monitoring of jets in active galactic nuclei with VLBA experiments. I don't know how they got Mojave from that. Active galactic nuclei with VLBE experiments. Okay. Is a long-term program to monitor radio brightness and polarization variations in jets associated with active galaxies visible in the northern sky, not the southern sky. Okay. The observations are made with the Very Long Baseline Array, which enables us to make full polarization images with an angular resolution better than 1 milliarcsecond, the apparent separation of your car's headlights, as seen by an astronaut on the moon. I don't think that astronauts on the moon can see headlights on Earth. I don't think so.
You don't think?
We'd have to talk to Mr. Armstrong, but
if there's no sun on that side of the moon, you don't think that they could see light? I don't know.
Scott, you just blew my mind.
I don't know.
You just blew my mind. I've got to think about that.
Clear skies?
We are using these data to better understand the complex evolution and magnetic field structures of jets on light-year scales, close to where they originate in the active nucleus, and how this activity is correlated with a high-energy electromagnetic and neutrino emission. This is the exact reason why I flunked a bunch of physics classes when I was going for a physics major. This right here.
Okay. Muses, not to be confused with musing, which stands for Multi-Messenger Studies of Energetic Sources, is a pioneering initiative in astrophysics. It is dedicated to the study of active galactic nuclei, which are among the most powerful particle accelerators known in the cosmos. These celestial bodies, harness the gravitational energy of matter accreted by supermassive black holes and convert it into electromagnetic and kinetic energy, resulting in the production of highly relativistic electrons and protons. The acceleration of protons and its relation to neutrino production is not well understood. I can't imagine why.
So let's just make it up, right?
Yeah, posing a formidable challenge to researchers. MUSES aims to address these fundamental questions by exploiting recent advances in multi-messenger astronomy.
Elementary, my dear Scott.
I guess.
It all made sense. But it sounds fascinating. An Eye of Sauron beaming at us from a black hole. That's pretty cool.
Sure.
I wonder if it's on the other side of the black hole, it's grabbing material and then accreting it out or jettisoning it.
There's a movie. There's a movie in production about this, I'm sure. Or a book, maybe. A book.
So Star Trek?
Write a book first.
Star Trek episode?
Maybe so. Star Trek or Star Wars, right?
No, Star Trek. Star Trek. Don't lead me astray.
Okay.
All right. Thank you very much for joining us, folks.
Take care, everyone. Thank you.